Okay, so today is about the law of cosines, and here it is. A squared plus b squared minus 2ab cosine c equals c squared. Now you may notice that there's other ways to write this formula. All they are is just rearranged and solved for different letters, but I think that's dumb. Because when they give you a triangle, do you think you're guaranteed to only be given A, B, and C for all triangles in your future? Of course not. So if I give you a triangle, you have to relabel it anyway, because I'm going to call it like FNP, and you have to be smart enough to go, oh, I guess my formula won't work for FN and P. I better relabel them with different angles, and I'm going to say they're A, B, and C. Now, if I tell you I'm only giving you one angle and it's this one, and there's no way that's 10 degrees, that's way too big, so let me think. Feels a little less than 45 degrees. I'm going to go with 35 degrees. If that's 35, everybody draw this triangle, label it FN and P, but we're going to relabel it in a second. Oh, you don't have a cell phone on you, have to. Good. All right. This is going to get relabeled with A, B, and C in just a second. Why? Because your formula has A, B, and C in it. Cooper, what do you think I'm going to call C? Nope, not going to pick P. Alex, what do you think I'm going to call the C?
It'd be whichever one you're trying to find.
Yeah, that's a good guess. But if I should maybe give you more information. Let me give you more information. Let's say this side length here is 10 and this side length here is 9. Now, why don't we just use the law of sines? Because you need an angle and the side across from it. Do you get I did not give you the side across from it? Then this is a good setup for law of cosines. And the law of cosines has only one angle in it. So therefore, what's the key angle here? It's angle F. So angle F is going to be our C. That should be C. Because we only have one angle. How are we going to use the law of cosines if we don't have the angle? We'd have to solve for it. It would take forever just to find that one angle. We're given an angle. Use that as C. All right, now, have I pounded this in enough? A and B don't matter. You still have to pick one. So I personally am going to cross these off and, like, really, I don't care. Sylvia, pick one. Which one do you want to be A? All right, we'll make this A. And then this is B, because it doesn't matter. I just need to be able to refer to it. The reason it doesn't matter, look, do you think if A and B are, which they are, 9 and 10, do you think it matters if I put a 9 here and a 10 here or the other way around? Of course not. We're going to get the exact same answer. It's going to be 81 plus 100 either way. So A and B don't matter. Do you think it matters if I do 9 times 10 or 10 times 9? No, they're right next to each other. It won't even matter. So A and B don't matter. All right, so now I'd like you to rewrite out from memory A squared plus B squared. Don't look at it. What is the rest of the law of cosines? A squared plus B squared minus... Somebody give it a shot. Raise your hand and tell me that you got this, Graham.
A squared plus B squared minus 2AB times cosine of C.
Cosine of big C equals?
Equals C squared.
C squared. Okay, good. That is the law of cosines. Now, I want to make a case that this is kind of like the quadratic formula. Would you agree that the quadratic formula has 16 parts and is kind of long and a little bit of a pain? But the quadratic formula also solves every single quadratic problem you've ever had. It can do imaginaries. It can do things where the graph doesn't touch the x-axis. It can do things that won't factor. But the quadratic always works, but it's a pain. This is kind of like that. Okay? This is kind of like the quadratic formula, and it'll always work for every triangle you've ever had. Now, are there times it's better than others? Yeah, but it'll do all triangles. But it's just harder because it's literally, I think I've roughly figured out how long it takes to use the law of sines versus the law of cosines. It takes twice as long to use the law of cosines. So if you can use the law of sines, do it because it's twice as fast. Okay, well, let's use this formula right now. I'd allowed Sylvia to pick, and she said A was gonna be 9. Okay, so then I'm gonna say this is 9 squared plus 10 squared minus 2 times 9 times 10. Cosine of C, which was 35. We did that on purpose so that it would work. We want our problem to work out, so we picked C to be the key angle. And then it equals C squared. I have never been given C, so I'm gonna put C squared. Now this is just, can you carefully type all this into your calculator? I would do some in my head. 81 and 100 is 181. Then I'd start typing it into my calculator from there, because I think you're more likely to make mistakes. So I'd go minus 2 times 9 times 10. I probably would have done 90 in my head. Oh heck, 90 times 2 is 180. I can trust myself. And let's see what you get. And don't forget at the end it equals C squared. So then you'll have to just take a square root of it. I'm going to pause for a second while you bust out the calculator. When you're done and you ask your partner if they're done, would you please compare with the person sitting across from you? Okay, I ended up getting 5.79. Raise your hand if yours was really close to mine, at least. Okay, good. Any questions? Happens all the time for people to forget the square root at the end. Also happens all the time that people mess up the order of operations and type it in wrong. So if you got like, what the heck happened there, try it again. If you type in exactly this on your calculator, it will work. As long as you're, oh, one more thing. If you haven't, sometimes when your calculator's bouncing around in your backpack, it gets reset to factory mode, in which case it's in radians. Remember, calculator has to be in degrees or your stuff's not going to work. If you got the same answer as me, you're in degrees. Yes? Nope, I get what you're saying. When we do the square root on both sides, we end up with 2 answers technically, but the negative side length, I love that you remembered that, the negative side length is inappropriate on a length of a triangle. Other than that, you were right. Okay. That's called the law of what's? Cosines. Let me give you another time when it's really handy. In fact, one of the slides is good at this, so we'll go into the slides. This is just reminding you of the... Let's actually label this one quick. We're not going to finish it, but this this ambiguous case is a big deal. This is big A, is 42. A is 17. That means this is 17, and it's probably both of these. But if I don't know for sure, I'd go figure out the height. I'm going to make it a blue line right here. That'd be my process for doing this problem. I also should label the B as 23.5, which is right here. And now, is this a good setup for law of sines? Yeah, I got the angle and the side across from the angle. Like I'll show you right here. That's why we were talking about this before we technically introduced the law of cosines. Even though I did tell you about it, that it was coming, we're just doing that for the first time today. So this is the law, this is the ambiguous case problem. What is the first thing you should do? Find the height. Would everybody please find the height right there? You don't have to, but I'm telling you, strongly recommend finding that height. To me, I would go sine of 42 and then do something with that. Did you guys get 15.72 for the height? Good, you did it right. But that doesn't answer the question, Mr. Server. No, but it does verify to me that this number here is between 15.72 and 23.5. So this number here does create the ambiguous case. The next thing you would do is try to find this angle, but then you wouldn't actually get that angle. You'd actually be getting this angle. I want to take a second and do that. Would everybody please try to find this angle? I'm highlighting it in green right there. But you'll end up getting this angle because of how inverse cosine works. You're going to do the law of, inverse sine, because we're going to do the law of sines here. In this case, weirdly, I'm not rounding to what they say. I'm giving it more decimal places. Nobody's ever going to be mad at you for in the middle of the problem not rounding quite as much because it'll be more accurate. At the end, you should round to what they say. Inverse sine of 0.905, and I got 64.8 degrees. Raise your hand if you got 64.8 or something that would be close to that. Uh-oh, not too many hands going up. Okay, I'm going to double check my work here. Hold on just a sec. I see the mistake. I did 23 times sine of 42, not 23.5. That's all it takes. So 23.5 times the sine of 42. So some of you rounded the same way I did. And then divide by the 17. And it was 0.925 right there. Not 905, 925. And then I go inverse sine of that. 67.66. Raise your hand if you had that one. Okay, that's far more people. Okay. Sorry about the oops. Just literally forgot to type a 0.5 because of that one right there. Okay, Jack.
How is that angle B?
It's B. B as in boy. Because I know you're thinking that's way bigger than 180. So you just found 67.66. I'm going to round it to 67.7, right? Let me double check that. 67.7 degrees. Then this is 67.7. And then this, you take 180 minus the 67.7. And I get 112.3. That makes sense to you now? Okay, good. Whenever you do this, you're finding this one. Because of how inverse sine works, the answer will always be less than 90. So you'll never find this one directly. You'll find it indirectly. Okay, let's go to this page. One of these can be done with the law of sines. Which one? Triangle 1, 2, or 3 is good for the law of sines? Talk with the person next to you. Which one do you think? Come here, lots of threes. Why is it 3?
Because you have the side across the lane.
Side across from an angle. Yes, that's what you look for. Okay, so let's not do that one. We've done enough law of sines. They're really easy. Let's do this one. The 80 and the 60 and the 20. Well, what are we going to do with it? Well, you already got all the sides, so what do you think we're going to figure out? An angle. Which would be the biggest angle? The side across from the... Yeah, the biggest side, which it's technically not called a hypotenuse in this case, but it is the biggest side. That one. That's the biggest angle. So, would you please call that angle Farfignugan? Okay, maybe not. What would you call it? C. The key angle is C. Now, you guys know what Farfignugan is? It's like a word in German for like excitement. Okay, so anyways, a squared plus b squared. Do you think I really want to write out that whole formula? No, I don't. So I'm going to just start putting in letters. Like, I know which letter is which. I personally am going to call this one A up here, and this one B, and the other one C. But you can reverse them, and A and B can easily be reversed. Okay? Now, this will get to be a pain pretty quickly. 20 squared I can do in my head, 400. Plus, but I have no idea what 60 squared is, so I grab my calculator, and I get, 36, I should have known that, 3,600. Minus 2 times A, which I'm just going to keep track of this, times C, times cosine of big C, but I don't know big C, but I'll solve for it, equals C squared, which is, this has got to be C then. which is 80 squared. 8 times 8 is 64. Add a couple zeros, 6,400. Other than the numbers being big, do you get you could solve that be using inverse cosine at the end? Let's not even do it. Do you get the setup? Any questions about how we set that up? That was a squared plus b squared minus 2ab cosine of big C equals c squared. On to this page. I personally think all of these are a big waste of time. They're just rearrangements of this formula, and I personally put equals c squared at the end because to me it flows better. Nobody ever starts the formula c squared equals. They always say a squared plus b squared equals c squared. So it's just got that little modifier in it. All right, now here's one I actually want you to try. Exercise 1. Figure out how long that is. I'm going to call it the red side. So you should pick A, B, and C appropriately. Put them all in, and in a moment, ask your partner when they're done and to compare with them, okay? But before we start, Jack, which one should be C? Of the three corners of the triangle, which one should be C? Hint. The law of cosines only has one angle in it, and it's what? The C is the key side, so that has to be C. That is the only angle we have. That has to be C. C is the key. Okay. Now, A and B you can reverse, and it won't matter. Your answer with the kid next to you will still be the same, no matter what you pick for A and B. All right, I'm going to pause for a second while you finish that one and compare with the kid next to you. Okay, for the sake of those at home, I think we better show how we did this. So a squared, I'm going to pick this to be A and this to be B, but I think you all know it won't matter. So it'd be 13.5 squared plus 16.7 squared minus 2 times 13.5 times 16.7 cosine of 36. All of that equals c squared, and this little side is c, and so then it's c squared, and then you do all of this, and then you take the square root of it at the end to get rid of the squared here. And what did you get? 9 point what?
9.82.
Anybody verify 9.02?
82.
Oh, 9.82. Can anybody verify that? Okay, good. All right. That's the law of cosines. But wait, this one doesn't even have an angle. Didn't Mr. Server say before that you had to have an angle? No, it kind of depends. If you only had the law of sines, do you get, with the law of sines, you'd have to have an angle? But here, we can use the law of cosines to solve this. We set one up like it before. Let's just talk about how you do it. Let's say I want this angle. How do I personally know that that is the smallest angle in the triangle? Because it's across from the smallest side. Okay, let's say I want that one. Well, then what do you think I'm going to call C? That one. That one's got to be C then. It's the key angle. Then you'd use the law of cosines, and this is A and this is B, or reverse, doesn't matter. And then you could do inverse cosine at the end to solve it. Do you get why this one has to be C? Because that's the one I want. If it's the angle I want, it's the key angle. I don't ever call it the hypotenuse. I call it the key angle. That's the angle that you either are using or it's the angle that you want. That should be called C. Okay, and now is the part where I'm going to tell you a few to do. We already did these, so skip that. On this page, we didn't do those before. And I figured out that I don't like this triangle because, look, it says 104 degrees. Does any of those look like they could be 104 degrees? So then we're throwing that problem out. This one, what the heck is that one that looks like a sprouted wheat or some kind of plant? It's actually a C. Very good. That one could be one of these three, and I can tell you it can't be that one because that one's over 90. And of the other two, I would make this one the one that's about 59.3 degrees. Stop putting your stuff away. That's inappropriate because you need to know which problems you're supposed to do. You're going to not do this one either. And you should definitely do the last two. Okay, the last two problems are word problems, and the test is going to be full of word problems in the R3s. If you don't practice them, you're toast. All right, that's all I got for you for today.